Hello, algebra students. These next couple of videos, Mr. Graff, Miss Erin, and I are going to take turns going over. So we're first going to introduce quadratics, and you guys have been solving quadratics. Now we're going to move on to looking at quadratics on a graph and seeing what they, how their graphs relate to their equations. So first, will you pause the video and write down these four vocabulary terms? And then we'll go over them. So a transformation, which is we're going to mostly be talking about translations as a type of transformation in this video, is a change in the size or position of a figure or graph. So there's five types kind of that we're going to look at. We're going to look at translations, which is what we're going to talk today in this video, reflections, stretches and shrinks, which we're going to do together, and then rotations, which we're really not going to talk much about rotations in terms of quadratics. An image is the figure or graph of a function that is the result of the transformation. So it's the copy of the original function. A translation is a transformation that slides a figure either up or down or left or right into a new position. And then the vertex, which we kind of talked about, is the point where the graph either changes direction, where it stops going up or it stops going down. So if we have a parabola that makes an N, this is the vertex. If we have a parabola that makes a U, this is the vertex. All right. So if we're looking at, this is just an image. This is obviously not a parabola, not a quadratic. If we sketch the image of this figure after a translation of 4 units down, or 4 units to the right and 3 units down, and then we're going to define coordinates of any point. So we're going 4 units to the right. So if I just take this point, 1, 2, 3, 4, and then 3 units down, 1, 2, 3. This is my new point. Here, if I go 4 units to the right, I'm actually going to go 1, 2, 3, 4. This is where it'll be. And 3 units down, it'll be like right here. Okay, so I'm going to erase that. And then here, if I go 4, 1, 2, 3, 4 over, 3 down, it should be about here. 4 over, 3 down should be about here. 4 over, 3 down should be here. And I should have the exact same shape, it's just in a new position. And these images, or these points over here that I've written off the graph might not be exact. But it looks like the same shape. So we're asked to define the coordinates of any point using x and y. So if we say that this x and y, this first one, was 1, 4, and it went to 5, 1. So the way we would write that is that we took our x and y, and what happened to the x? Well, 1 to 5, we added 4 to it. So x was added to 4 by 4, and y decreased or subtracted 3. So that's a transformation. That's a transformation rule. We have an x change and a y change. Okay? So then an example of a parabola changing so we're given the parent function, and we've talked about parent functions. This is the parent function, y equals x squared, where 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, negative 2 squared is still 4, negative 1 squared is still 1, negative 3 squared is still 9. And we've translated it, okay, to this image in red. Well, let's just talk about how it moved. First of all, if I trace, and I'll do it in blue, if I trace this parabola, my question is, if I move that green parabola down to the red one, is it going to be the same size? Because looking at it, this red one looks bigger. But actually, if I trace this down here, it's the same size. It only looks bigger because we see more of it. Okay? So it's the same size of parabola. It hasn't shrunk or stretched at all, and we'll get into that in a couple videos. But this one is just moved. So we're just saying, how has it moved? It's moved, it looks like, over 2 and down 4. So we would say the transformation has moved the parabola to the right 2 and down 4. Okay? Now, there's a connection to parabolas that, or there's a connection to the equation of this parabola that moves the shape. Okay? So I'm going to teach you this new form of writing an equation. You guys know the form ax squared plus bx plus c. There's this new form that I'm going to teach you where it's y equals x minus h squared, or a times x minus h, plus k. Okay? This is called vertex form, where h is the amount we move over and k is the amount we move up. Okay? So the trickiest part here is that it's minus h. So since we moved right 2, this is actually going to be x minus 2, even though that doesn't really make sense. And then since we moved down 4, that'll be a negative 4. And then what ends up being really cool is that this, this point, the point HK, is our vertex. And you can see that point is 2, negative 4. Okay, so I just introduced that in this video. Your teachers are going to go over a couple more problems in class to kind of solidify that.